Good morning to everyone. Today we are discussing about the third unit. Third unit name software designing. In this software designing, we have covered various topics. Those topics are abstraction and modularity software architecture and effective modular design and cohesion and coupling architecture design and procedure design and finally data flow oriented design. So these are the topics covered in this chapter. So we are discussed about one by one. So what is a software designing? So generally the software designing is an iterative process through which requirements are translated into a blueprint, that is for constructing the software. Okay, so live example, we have to ready to construct an apartment. So without any designing, we have not ready to construct any apartment. So basically we need a designing pattern. Based on the designing only, we have to ready to construct the something, that is the called apartment. Okay, that is the example of the designing pattern. Initially the blueprint depicts a holistic view of the software. Okay, so generally designing patterns, how can you representation designing patterns in SDLC framework? So see the diagrammatic representation of the designing, the software designing in typical, first of all system engineering, then after requirement analysis, after that designing, then after coding, after that testing, finally deployment. But we are discussed about the today topic designing. So but in this designing topic consisting of the high level designing documentation, detailed designing documentation, integration testing and unit testing. It's a part of the designing. And also software designing, we can consider the some of the following rules. So those are compatibility, extensibility, maintainability and modularity and reusability, robustness, security and interoperability. So these are the software designing considerations. So first of all, compatibility. Compatibility of software to work in different platforms. The compatibility means we can work in different platforms. We not only single platform, we can work in different platforms. And coming to next one, extensibility. Extensibility means incorporate of additional capabilities without changing base architecture. We can add more functionalities, we can add more capabilities without changing the base architecture. Next one, maintainability. Maintainability means easy to manage, fix defects, perform enhancement. We can enhancement means we can defect the errors. And next one, fault tolerance. Fault tolerance is consisting of the able to recover from component failure. And coming to the modularity. Modularity can be consisting of the software contains number of well-defined modules for the better maintainability. Means we can define more functionality, number of. Okay. So reusability. The code can be reused with minor or no modification. That is called reusability. And robustness, it can be consisting of the better performance under stress. And security it can be consisting of the protecting the information from the unauthorized access. And also finally interoperability means system can be interrupted with other applications and components. These are the software designing considerations. Next one, process of designing engineering. During the designing process, the software specifications are transformed into designing model. Okay, transformed into designing model. What you have to take in the specification, those specifications are transformed into designing models. So here, what is a model? Model describes the details of the data structure, system architecture, interface and components. Okay, model describes the details of the data structure, system architecture, interface and components. Each designing product is reviewed for quality before moving to the next phase. Means designing after what step we can go? Designing after we can write coding part. So that is the definition here, this sentence. Each designing product is reviewed for quality maintenance before moving to the next phase of the software development. All the end of the designing process, a designing model and specification document is produced. Okay, this documentation is composed of the designing models that, that describes the data, architecture, interfaces and components. So the diagrammatic representation of the designing process, analysis model as well as the diagrammatic representation of the analysis model, the designing model. See, circle and pyramid symbol. See, so this is the difference between how can you moving the information, exchanging the information, how can you call. So this is the analysis model and the designing model. There is a communication. So in this diagrammatic representation, see here the analysis model is can be consisting of the data dictionary as well as the entity relationship, data flow diagrams and control specification diagrams, everything you have to. So based on that, how can you define the interface design? So this is the diagrammatic representation of the analysis model, designing model. So designing specification models. Interface designing describes how the software elements communicate with each other with other systems. That is the called interface purpose. Okay. So what's the main role of the interface? Interface is the key of the interface role is describes how the software elements communicate with each other with other systems and with human users. The data flow and control flow diagrams provide much of the necessary information required. Okay, coming to next one, procedure component level design, created by transferring the structure elements defined by the software architecture into a procedure description of the software components using information obtained from the process specification. PSPEC means process specification and control specification and state transition diagrams. Means how can you represent the information process? So we can representation on the control specification as well as the state transition diagram. So these are the diagrams we are last section we are discussed. Okay. And next one, the designing process. Software designing is an iterative process. Iterative process through which requirements translated into a blueprint for the construction. I already defined this definition previous last slide. Okay. The software quality guidelines and attributes. So what are the software quality? Quality means how much quality, how much produced exactly. That is the purpose we are using quality, how much quality we can provide. So basic we are using some of the guidelines or and attributes. So those are the designing must implement all of the design must implement all of the explicit requirements contained in the requirements model. So the designing must be a readable and understandable guide for those who generate code and for those who test and subsequently support the software. So the designing should provide a complete picture of the software. See, again I can repeat this same sentence. The designing should provide a complete picture of the software, addressing the data, functional and behavioral domains from the implementation of perspective. And quality guidelines in order to evaluate the quality of designing representation by creating a user recognizable architecture style or patterns. Means you can recognize it by the user. So that is the part of here quality guidelines has been created using recognizable architecture styles or patterns and composed of the components that are good design characteristics can be implemented by an evolutionary fashion. Okay, evolutionary fashion. And quality attributes it can be consisting of the functionalities, usabilities, reliability and performance and supportability. So functionality is assessed by evaluating the feature set, and capabilities of the program, the generality of the functions that are delivered, and the security of the overall system. So what is a usability? In assessed by considering the human factors, overall aesthetics, consistency and documentation. Reliability is evaluated by the measuring the frequency and severity of the failure. Okay, severity of the failure, the accuracy of the output result. In reliability, it can be consisting of the, it will be produced accuracy of the output results. The mean time to failure. MTTF means mean time to failure, the ability to recover from failure. Okay, and the predictability of the program. And what is the performance? Performance is measured by considering the processing the speed, response time, resource consumption throughout, and efficiency. That is the purpose of the performance. What is it? Supportability. Supportability combines the ability to extend the program, adaptability, serviceability. These three attributes represent a more common terms. Maintainability, and maintainability, it can be consisting of the addition, testable, compatibility, configuration, easy with the which each system. Okay. So generally the designing concepts consisting of the abstraction. What is a abstraction? So different level of abstractions are developed. You work to create both procedure and data abstraction. What is a procedure abstraction? Procedure abstraction refers to a sequence of instructions that have a specific and limited functions. An example of procedure abstraction would be a word open for a door. Open for the door. Open implies a long sequence of procedure steps. For example, walk to the door and reach out and grasp knob, from the knob and pull door. Step away from moving door. So this is the procedure we have to follow step by step. That is called sequence manner. So what is a data abstraction? Data abstraction, collection of data that describes a data object. In the context of the procedure abstraction open, we can define a data abstraction called door. And architecture. So architecture, overall structure of the structure and the way in which the structure provides conceptual integrity for a system. A set of architecture patterns enables a software engineering to solve common designing problems. So structure properties, it can be consisting of the representation, means architecture design representation defines the components of a system. Example, modules, object, filters. These are the examples of the representation, and the manner in which those components are packaged and interact with one another. So extra functional properties. How the designing architecture achieved requirements for the performance. Capabilities like capabilities, reliability, security, adaptability, and other system characters. These are the extra functionality properties. Families of related system should draw upon repeatable patterns. Means repeatable patterns that are commonly encountered in the designing of families of similar systems. We can repeatable. What you have to defining the repeatable statement. Model represents the architecture as an organized collection of program components called structure model. So here framework models consisting of the increase the level of designing, means increase the level of designing abstraction by attempting to identify repeatable architecture design frameworks that are encountered in similar type of application. And coming to next model, dynamic model. Dynamic model indicates how the structure or system configuration may change as a function of external event. Process models focus on the design of the business or technical process that our system must be accommodate. So pattern here, see pattern it can be consisting of the, it's a designing pattern. Okay, provide a description that enable designer to determine what type of determine whether the pattern is applicable to the current work or not, whether the pattern can be reused, means saving the design time. Reused means we cannot repeat it the same number of times. Once you can use one pattern, you can use number of times. Based on that one, we can save the designing time. So whether the pattern can be served as a guide for developing a similar but functionality or structure different patterns. And separation of the concerns. Separation of the concerns is a designing concept suggested that any complex problem can be more easily handled if it is subdivided into pieces that can each be solved in optimized independently. That is the purpose. Separation of the concerns means what you have to defining the big problem, big functionality, it can be divided into submodules and easily we can solve. These are the separation of the sequence. And what is a modularity? So modularity is the most common manifestation of the separation of concerns. Software is divided into separately named and addressable components, sometimes called modules, that are integrated to satisfy the problem of requirement. The diagrammatic representation C. And coming to the next one, information hiding. The use of information hiding as a designing creation for modular systems providing the greatest benefits when the modifications are required during testing and later during the software maintenance. What is a functional independence? Functional independence is achieved by developing the modules with a single-minded function